But first, a presentation on life cycle assessment. So we first aim to explain life cycle assessment in general, so you have a bit of an understanding of what it is, what it can do, what is the use of life cycle assessment in general. And then we go a bit more into depth on how it's being applied in the Eco-Ready project. And then we will go to some examples of results, of the baselines and of the scenarios to make it a bit more practical. So let's first go through the LCA basic concepts, because not everyone here might be aware of what is life cycle assessment. So life cycle assessment is a method to quantify impacts. And yeah, we use it in this project to quantify the impact of food products, agricultural products, and it is being used to quantify the impacts along the life cycle. So that's why it's called life cycle assessment. So you identify all the stages a product goes through. And yeah, it's a standardized method, and yeah, quite reliable and transparent. And you can do it to quantify impacts for the environmental side, also social impacts, and also economic impacts. And if you combine all three of these, you incorporate all pillars of sustainability. So in this project, we applied it for the environmental and the social impacts. And we focused on the first part of the life cycle. So we call it from cradle to farm gate, because the main focus of the Eco-Ready project is on identifying hotspots in the farming stage, let's say. And some impacts you might think of are, these for the environmental side. So, like climate change, water use, land use. And for the social side, there are also impacts on like the livelihood of communities, on the working conditions of farmers. And that is, in a nutshell, about LCA. And yeah, what is then the goal of an LCA? So if you have quantified all these impacts, that will give a lot of information. So it helps to identify hotspots in the life cycle to see what is contributing the most to these impacts. This will give information for people to potentially mitigate these impacts, so social and environmental. You can compare products, so you can do a similar life cycle assessment on similar products in different countries to see what are the differences on different systems. It can help to identify trade-offs, also, to see where to source from, for decision making, and it can highlight the risks and also give insights for opportunities. And overall, it should be used to stimulate dialogue and increase awareness of where are the hotspots and how can we, find things that contribute the most to really. To put your action into the right parts of the value chain to make sure to minimize the negative impact and to improve the positive impacts. And these goals can serve for certain applications, so to optimize processes, to compare, but also for eco-labeling, for example. So you can classify communicate to consumers about the impact. It can be used for reporting requirements, for policy support, and also for marketing, for reporting, and as I said already, for support in decisions. So that is in a nutshell what you can use it for. Then a few key concepts, no need to read this in detail, but just to make sure you are aware of some terminology I might use throughout the presentation. So we talk about impacts. So that is the actual effect on the environment or certain stakeholders. So it can be social and environmental, but there's a differentiation in some methodology we will use. I will present later on with regards to the actual impact and the potential impact. So we do assess some actual impacts by collecting really primary data from what we are studying. So let's say from a farmer, but there's also potential impacts if we use modeling, or future projections there might be certain risks we might see, which are not one-on-one, they do not have to occur, but there's sometimes a higher risk in a certain region or a certain part of the value chain. Hotspots are the part with high potential risk or impact in the value chain. And then we have the terms footprint, which most people are aware of. So the quantified results of across the life cycle, but there's also handprint, which is more the positive impacts, more linked to certain social impacts like technology development or contribution to economic development. So we don't only want to talk about the negative impacts, but also about the social impacts or the reduction of the negative impacts, also positive. And there's also the performance. So you have the impact and the performance is relative to a benchmark or a target or a standard. So just to make sure you understand the terminology used. And let's go through some basics of environmental and social and which data we are using. So we understand the basics here. So the inputs for an environmental LCA can be like primary data, as we call it, or secondary data. So primary can come ideally, straight from a source, straight from a farm, which was what we did in this project. So we asked for example, fertilizer use, pesticide use, water use, if necessary, like feed intake, manure, and of course yields. And ideally, you collect as much primary data as possible to make the impact assessment as accurate as possible. But of course, that's very time consuming. So often in LCAs, you see that one part, the main part, the focus part of the study is being done with primary data. And the other parts are filled with secondary data. And that is based on databases or statistics. And there are certain LCA databases we can use so we can model to fit together with the primary data we collected. So some examples are Eco-Invent, Agribalise. And then we can put that together to have a complete picture of all the data and all the inputs. And what would then be an output of an environmental LCA? So all of these inputs are modeled, and then what comes out is the environmental impact on certain topics, as I already presented briefly before. So that would be the carbon footprint, for example, water footprint, acidification, eutrophication, things like that. I will present later the examples of the results and what it might look like. And then for the social part, same applies. So we have primary data and secondary data. And primary data might be for us to understand what does the workforce look like, how many people work at a farm, do they work part-time, full-time, what are their roles, working hours, are they paid above minimum wage, did any accidents happen, things like that. Also topics like animal welfare can be considered, indigenous people's rights. It's very broad, these social impacts. So in total, there are 40 social topics, but it depends usually on the study and the geographical focus area, what are the topics to take into account. And then, of course, we also have the secondary data, so based on databases or also statistics. And those are PSILCA and Social Hotspot database. There are also many more. And this, they kind of map out based on other sources, certain topics and the risk levels amongst many countries. Picture you can see on the right, for example, they have here animal products and then occupational toxics and hazards. And then they kind of mapped the level of risk in these countries for that. So this we also use as a backup with the primary data to see how they compare. But usually these background databases, at least for the social parts, they are quite on an aggregated level. So that's a pity. So we have to take that into account. So it's not very product specific, but more sector specific. And as I said before, there are many social topics you can take into account, but usually not all of them are taken into account because it's not always relevant. So first, in a study always start with an assessment of what are relevant social issues in this value chain in this region. That's called a materiality assessment, so that you really target the data collection. So you're not gonna collect a lot of data for potential topics that are not so relevant in this region. And you can do that based on expert judgment, also doing interviews, but also looking at the news and other databases to assess potential risks. That is about the inputs and the start of a social LCA. And then about the outputs, what will you get out of a social LCA is to really identify the hotspots. So you get a quantification of the social impact or the risks. It depends how you conduct it. So that can be on topics like the fair salary, the working hours, whether there's any child labor, distinction made between the actual impacts or the potential impacts. And for example, you can identify improvement potential. So that is the basics of LCA, very much in a nutshell. So there's way more to LCA, but that's not the aim of this webinar. We're going to focus mostly on how we applied it in the Eco-Ready project and focus on some examples of results here, rather than really how the modeling works in LCA. So let's go to what we did in Eco-Ready. So in Eco-Ready, the goal was to assess the environmental and the social impacts of certain food products in order to gain insights into the impacts right now and how they might develop towards the future. And all of this will be put into the observatory, as Jan has already mentioned. This is a platform, and users can gain insights, they can play with the results and see potential scenarios and how things, what are hotspots and how these might change. So we hope with the LCA we can give some insights, we can quantify some of these, and we are working on scenarios, so it will be food for thought for users to see if we change this, then the impact might change like that. So it hopefully will create some awareness and reflection opportunities for potential hotspots and how to mitigate these. And then we had to go to select some products. So all the living labs, there are 10 living labs, all of them have a selection of products. And we, in the end, made this selection of products. So we have industrial tomatoes, mushroom, barley, wheat, and leafy greens. And we chose to have certain products multiple times in different countries, so in different living labs, so there's some clustering, so that hopefully we can identify some trends that within the production of this product in this country, to see if the impacts are similar when it's produced in another country or not, and if they face similar challenges in the future as well. And there's some organic and non-organic products. So this is the selection of products we assessed. So we did 10 baseline LCAs, let's say, and we collected 10 times the primary data from farms in these countries. And that is one part of what we did. And this is the full picture of what we did. It might look a bit complex, but I'll walk you through it. So what I just explained is the top left, so the baseline and a primary data collection from living labs. With that, we did quantify the impacts. If you go down, so the environmental and social baseline impact assessment. So we have insights into their hotspots at the moment. So we quantified the impact of the reference year, which was for most living labs 2023 or 2024. And then we can already learn a lot. But we also wanted to go towards the future to see how might things change under different scenario assumptions. So that is the right-hand side, the scenarios. And there are multiple ways we went about this, because of course, when you talk about the future, everything is uncertain, and there are multiple approaches to take here. So we tried to follow a qualitative and a quantitative approach to get the full picture, hopefully. So in the middle, you see the SSP scenarios. So we try to link our baselines to the SSP 1, 2, and 3 scenarios. And we combined here LCA with magnet. And many of you might have been at the webinar last week that Jason presented about magnet. So if you want to understand more about magnet, I would advise you to rewatch that webinar, because it was a full hour on magnet and the assumptions made there and the outputs. So we will not go into too much depth here on magnet, but we use the output of magnet, which uses these SSP scenarios to adjust our inventories, as we call them. So the inputs, the input data. So we have the actual input data from the farmers, and now with the magnet projections, we adjusted these based on their assumptions. There will be a few slides about this later. And based on that, we did some scenario quantification. So for these SSP 1, 2, and 3 scenarios, we quantified these as well. And so then we have the baselines and the scenarios quantified. All of this will be fed into the observatory later. And then totally on the right-hand side, you see that also these living labs themselves, they also have identified certain scenarios of how they foresee certain challenges towards the future. And this ranges a lot from extreme weather events like droughts, floodings, but also market situations like more demand for organic products, for example. And yeah, we talked about these scenarios in a workshop, mainly focusing on the social implications of these. And we talked with the living labs about how they foresee these assumptions of these scenarios, how they foresee in a qualitative way that things might change from the baseline towards the future. And next to that, we also did some literature reviews on the environmental implications of these scenarios. And in that way, we hope to also have a more qualitative reflection on how things might change towards the future. And all of this we will put together in the final deliverable, so the quantitative part and the qualitative part, to reflect on, in a holistic way on the current hotspots, environmental, social, in different countries for different products, and also put these into the context, the qualitative part. But only the quantitative part will be fed into the observatory. So I hope, that this is understandable. And now we will go a bit more in depth on mainly the quantitative part and the rest of the presentation. So let's go through some examples of the outputs. And now we first focus on the baseline. We will use the example of organic wheat production in the Czech Republic, which is one of the living labs, and the results we got for this living lab. So in LCA, so this is what we call the system boundary. So that's the part of the system we take into account. And as I mentioned before, we focus on the cradle to farm gate. So we don't take the further processing and transport and consumption of the wheat into account here, because we focus on the hotspots in the first part of the life cycle. And all of this, all the inputs are linked to a reference unit, which is in this case 1 kilogram of organic wheat. And then we collected all the information together with the living lab. We identified all the inputs specific to this farm. So you can think of the fertilizer, the starting material, water use, the diesel use, etc. And it was organic, so no pesticides used here. And then we got all the amounts that they use for the total yield they have in that year. And then it's good to identify that there's upstream impacts and direct impacts. So everything under the control of the farm itself, and everything that they source from other places, which is also taken into account in the impacts, but it's good, especially for the social part, to make this distinction between upstream and direct, which will be clear in a few slides as well. And as it said at the bottom, so we collected data from the living labs itself and certain background data from databases like Eco-Invent and other literature sources. And this is the output. So it's a big table, but this is usually the result will be quantified amongst these topics. And yeah, you see the impact category, the units, and the numbers. Yeah, so usually it ranges like from climate change to acidification, eutrophication potential, etc. And as said on the right-hand side, we walk you through the biggest hotspot. So yeah, we can walk through the field emissions and the cultivation. Also, the diesel use is quite a hotspot, and the starting material and electricity. So as you see here in this table, this is the sum, the overall impact on these impact categories. But of course, there are different, let's say, processes contributing to these. So it's good to go a level deeper to see what exactly is contributing to it. So let's go to an example. So here we have the climate change impact category. And you see the total number of CO2 equivalent. And then here we can dive a bit deeper. So we have 0.495 kilogram CO2 equivalent in total. And then what is contributing to that? So which part of the life cycle, which stage? And as you see here, it's mainly the diesel use for alfalfa cultivation, but also the diesel use for wheat cultivation. So, and you see, for example, the inputs, the starting material for wheat and the alfalfa was way lower. Yeah, so this is how we can really trace back where the impacts come from and what are the hotspots, so farmers can focus on the identification of these and potentially reduction. And we can also look at the contribution type of the emissions. So if we zoom in into the climate change potential for this organic wheat, you can see here, for example, that 70% is carbon dioxide and 23% dinitrogen monoxide. Yeah, and all of these are greenhouse gas emissions contributing to this impact category of climate change. So that is a bit of a deep dive into the results of the baseline of the environmental side. And then let's go to some baseline results for the social side. So here we also collected data from the farmers themselves on certain social topics. But first of all, as I said, you have to do the materiality assessment. So we had some surveys with all of the farmers involved, and also some expert judgment to identify in Europe, in these agricultural value chains, what might be potentially risky topics. And then we came to this selection based on the stakeholder consultation. So that's working hours, fair salary, smallholder farmers, occupational health and safety, technology development, and contribution to economic development. These all were considered the most important topics. So for these, we went on and collected primary data on indicators like these. So that is, you really have to target the primary data because it's quite time consuming. But then also we wanted to include secondary data. So with the databases to zoom out of this one specific farm, but on a country level, on the whole agricultural sector, what are the risks based on statistics, to put it into perspective, to say, okay, the primary data says this, but in general in agriculture in this country, there are mainly these risks, so we can have the full picture. And we can also compare to see if it applies or not, also to the specific farms. And then next to that, as I said before, we also did a workshop to see in a qualitative way what risks they might foresee towards the future. So what we did with the primary data, so for this selection of topics, we identified certain performance indicators, and based on these, we collected data. And these indicators were then put on a reference scale. So usually in social LCA, one works with reference scales to identify certain levels of this indicator where it's above a threshold or below a threshold. So an easy example is the salary. So a threshold would be minimum wage, and then you can identify certain levels above that, or if it's really paying below that, then it's a risk, let's say. So that is for the direct impacts, like what we assess with primary data. And then we also assessed with secondary data based on the databases. So Social Hotspot and Psilka, we used both. We also identified, like we tried to model the life cycle, all the inputs that this farm everywhere it's sourcing from, like the fertilizers, the diesel use, starting material. We try to model all of that and then see what are the hotspots based on the databases. And the databases work in a bit of a similar manner. So they also have certain indicators. And for that, I would refer you to their manuals if you want to go into a lot of depth here, because we're not going to discuss it in depth here. But for every topic, they have certain indicators and they have determined certain risk levels. So whether it's in this range, it's considered low risk. If it's in another range, it's considered high risk. So then you have a risk level and you have the exposure to the risk. So the amount of working hours in this risk. So there might be, let's say, a high risk in a certain production of a certain fertilizer, but you're only exposed to it for 1 hour. Then it's, you have a low amount of hours times a high risk level, but you can also be working a lot in another part of the value chain with a low risk. So then it's a lot of work hours times a low risk score. And then the final unit we work with is then medium risk hours. And then let's go through some results here. What is the output of this then? So on the left-hand side, you see the assessment for the primary data. So we put all the indicators against like reference scales, and then we could conclude certain things. So we mainly conclude here in a qualitative way. But overall, we saw that, for example, the occupational health and safety performance was quite good. There were no accidents reported. And all the protocols and certifications, etc., were in place. And we assessed this for the other topics as well. So that is the direct impact with primary data. And on the right-hand side, you see the outputs of the modeling part for the upstream impacts. Because this is potential risk. So this is risks. This is not actual impact because it's just based on secondary data sources and statistics in these databases. So it's not said it links one-on-one to this living lab, of course. But this is based on wheat in Czech and modeling the size of this farm and the amount of inputs they get from certain countries. Then we see these risks, and you see here the unit is then the medium risk hours. And then in the final results, we will put this together for a full, complete picture. And then for the selection of topics for the direct impact, we also put them into perspective. So this is one example of occupational health and safety. So as I said, we saw a good performance for this specific farm based on the data they provided us. But then we also put it into perspective with literature and to see, is this one farm, is it representative of the scoring, let's say? Because in general, occupational health and safety is quite a risk in agricultural sectors because the farmers work a lot with heavy machinery and generally like pesticides and fertilizers. But so to set the scene, to provide all the context that it's usually a high risk, but in this farm, for example, because maybe they didn't work with pesticides because it's an organic production, it might be that they score well, or they have all the protocols in place, so therefore the accident rates are lower, etc. So that we aim to really put it into context here, and we do this for all these topics. And next to this, so we have the direct and the upstream impacts quantified with LCA. Next to that, we also wanted the farmers' input on how they foresee things to change towards the future. And therefore, we also used a future wheel approach and to identify, to get them thinking about, okay, if there would be a seed of change, we call it, a certain scenario or assumption, what would be the first order consequences of that? And based on these first order consequences, what would be the second order and the third order consequences? So to get more insights into their expectations towards the future. So we identified certain seeds of change, and we also have a full report on their expectation on this. And this is one example of the adoption of a milking robot. So this is not linked to the Czech wheat example, but just to provide an example of potential impact. So we didn't quantify here, but just to get the narrative. And also certain social topics obviously cannot be quantified. So we want to have certain ones quantified, but also really reflect on these that are very hard to quantify. And then all of this will be included in the observatory, so the environmental and the social risks per living lab, let's say, so per this product, and based on the primary and secondary data, we have the overview of their impacts. But next to that, we also included not living lab specific, so general risks. So we also have, based on the databases, all the countries in Europe and all the impact categories, so the social topics, and then just the risk level. So we didn't quantify it here to go to a certain impact, so not to go to medium risk hours, but just to identify the level. Like, is this topic high risk, low risk, based on how it's modeled in these databases? And then you can get an overview. This is very aggregated, so very much on sectoral and country level, but still it might give some food for thought, and you can always trace back in the manuals of these databases where exactly is this based on, like what exactly data is underlying here. So this is all about the baselines and the reference year we took there and the actual inputs. So let's go to how we modeled the scenario outputs. So as I said last week, there was a presentation of Magnet, and he also showed this slide, and how Magnet is also feeding into the observatory, but also into LCA, and then LCA again into the observatory. And obviously there's also the deliverables if anyone's interested in reading them. But let's provide a very brief overview of what Magnet is doing for the ones that were not there last week. But Magnet can provide quantitative future scenario projections. And this is used a lot for policy recommendations, but in this case also to feed into life cycle assessment. And we have to say this is really a first attempt to match these, so it's not, later we also reflect on the limitations of this approach, but we're really exploring here if we can combine the future projections and the SSP scenarios of Magnet to really link to the quantification of impacts, because that would be really useful. So we're really trying to fine-tune this approach. So as I said, Magnet is a foresight modeling tool for long-term simulation. So it's a macro equilibrium model. And it's used to model the global economy, let's say, and all the sectors in it. So it's economy-wide, global coverage with national level aggregation. So they don't have the level lower than the national. And their key strengths are the trade-offs between objectives and domains, a multi-scale and ex-ante evaluation of policy impact. So they can include shocks into the system and then see how does the economy change, where do certain sectors source from instead if there's a certain shock included, and how much, and under certain scenario assumptions, how does the future change. And we will focus on 3 scenarios in Magnet. So that is the SSP1, 2, and 3. So the SSP1 is the green road. And this is assuming a greener, more inclusive, integrated world with low challenges to climate action and adaptation. There's the SSP2, which is the middle of the road. So that assumes moderate economic growth and development with balanced challenges to climate goals. And there is the third SSP which is the rocky road, a fragmented world marked by nationalism, slow growth, and high challenges to mitigation and adaptation. So if you have questions about all the assumptions underlying, I would really refer you to last week's presentation. But for now, we just assume these, and then we go into how did we link this to LCA. So if we go to the wheat example again, to wheat from Czech Republic, organic wheat, yeah, then you see here some key outcomes for SSP1, 2, and 3. So for example, in SSP1, we see a reduction in wheat production and a reduction in yields, but an increase in energy efficiency, for example, and a decrease in fertilizer purchased in the sector. So yeah, we get all of these percentages from Magnet, and we try to match that to our LCA inventory. And for example, for the middle of the road, you see no increase in wheat production. However, in the rocky road again, you see an increase in wheat production. So you see there's different ways the future can go about for sure. And with this, we aim to provide certain scenarios we can think of. So in the rocky road, for example, there's also an increase in fertilizer purchased. And how does this then work out in our LCA quantifications? So here you can see some charts and then the development over the years. So from 2025, which is our baseline, towards 2050. And then you see the line. So the green one is the green road, towards the red one, the rocky road. And you can clearly see under the assumptions of the green road scenario, for example, the fertilizer use is going down, and for also the chemical use per ton of wheat is going down over the years. And the opposite is for the rocky road. So you really see that in the green road, there's a shift to more extensive production methods and a reduction in fertilizer and chemical use, but an increase in land occupation, for example. And it depends a lot on the product we take into account, because, for example, in this case, it's organic wheat, but we also have other living labs which are non-organic, and then we can see differences there potentially. But maybe very different trends for other products like the leafy greens, which are from vertical farms, or from the mushroom or tomato production. So yeah, some more visuals. This is on the climate change potential for wheat. And then you see the different percentage changes in the 3 SSPs in the 2030 and 2050. So you see an overall reduction, but the most reduction in SSP1 in 2050, and the lowest reduction is in SSP3. Yeah. And then for social, we also modeled, as I showed before, we have the upstream impacts, and we quantified this with the database. And you see here on the total left-hand side, the baseline impacts in medium risk hours, and then the development of these over the different SSPs. And here we see a similar trend. So we see the biggest reduction in impacts is in the SSP1, and the biggest increase in impacts is in the SSP3. And yeah, it just shows a selection of impacts to visualize here, but there are many more, which also will be included in the observatory. If anyone is interested, you can really play with all the results later when everything is included there. So then you can see per topic, what is going up and down by how much, by which year, based on the assumptions of the scenarios in the output of Magnet. Of course, there are some limitations as well, or some things we have to note about this methodology. So as I said before, this is really a first attempt to match such a macroeconomic model together with LCA, because LCA is very, case-specific, region-specific, with impacts, with like primary data. And we match this with a very big macroeconomic model, which is on a more aggregated level. But still, it gives a lot of nice insights, but we have to also note that, Magnet is producing output on sector level, and LCA, here we really have like product specific. So there's different scaling there. And also it's quite a static assumption, because, for example, for social, of course, there is many dynamics. There's cause-effect relationships and drivers for certain social impacts, and these social impacts are all interrelated. So let's say if there's certain if there's not enough income for a family, let's say, then there's impacts on maybe the education opportunities for the kids, or certain child labor, for example. But in this case, we couldn't really capture these trends quantitatively because we just assumed, based on the magnet outputs, that the inputs would increase or decrease based on the SSP scenarios. And therefore also, so if there's a certain risk from sourcing from a certain country, it would just become bigger if more is sourced from there, which is also the case. But also in these scenarios, there might be other dynamics as well in the SSP 1, 2, and 3, which could not be included here now. So in that sense, it's static. Yeah, there's the trade representation. So it's using global trade averages. So limited reflection on specific sourcing changes. And also not all of the living lab scenarios, so on drought and heavy rainfall, etc., could be taken into account quantitatively, because that's very hard to capture with LCA, because LCA is really focusing on inputs and outputs. So all the inputs per ton of wheat or kilogram of wheat. And yeah, sometimes these scenarios are very hard to capture quantitatively, but therefore we really put all these quantitative results into context, and we added the qualitative part as well, and we got all the reflections from the farmers about how they foresee the future changing. So we really tried to put the quantitative results in the context with all the qualitative reflections, and also embed it into literature, how literature is foreseeing things to change towards the future. So we really try to combine the primary, secondary data, but also quantitative and qualitative. So how will all these results, so the baseline and the scenario impacts, will be included in the observatory. So yeah, users can play with it. They can see trends. They can select certain topics, certain products, certain countries, and see how impacts might change, and determine for themselves whether it applies to them. Because these numbers are not, it does not have to be like that, but it's more like food for thought about how things can go, and it might serve as a reflection to identify in your value chain, does this apply as well? Do we also have these inputs? Do we source from certain of these countries? And to reflect on whether these risks might be as well applicable or there in your value chain. So it might give feedback to the living labs about their hotspots. It can help for policy recommendations, the quantitative part, but also really the qualitative part. And yeah, there will be a lot of food for thought about how there's different pathways towards the future, how things might develop, which might help in reflecting on these pathways and already mitigating to have a lower footprint and potentially increase the handprint. Yeah, that was it. So this was the presentation. Thank you all for listening. And I think now we can go to some questions if any are there.